Hi, I'm Jan Segert. I'm from the Mathematics Department of the University of Missouri, and I'm interested in differential geometry, mathematical physics, algebraic topology, and also recently in data science, machine learning, topological data analysis, and things of this kind. So I'll be talking to you about a preprint that I posted in the archive about a year ago. And what we'll be doing is constructing solutions of the Painlevé 6 differential equations from equivariant instanton bundles. So let's try to unpack some of these things. So first of all, the Painlevé 6 equation, or P sub 6, is it this nonlinear second order differential equation of a complex valued function of a complex variable, and it depends on a set of 4 parameters. What's interesting from our viewpoint is this action of Schlesinger-Okamoto transformations, that if you have one solution, depending on some parameter, you can transform it to another solution depending on another parameter, and these Schlesinger-Okamoto transformations act on the parameters and on the function by explicit birational transformations. Okay, and so algebraic solutions of Painlevé 6 are rather rare, but they're very interesting. There was a lot of activity on this in the 90s. Here's some of the key names that were involved. What we'll be doing is focusing on one of the constructions of Nigel Hitchin, where he takes an SL2 action on CP3 with an open dense orbit, and then from that produces an isomonodromic deformation by deforming lines in CP3, and from that constructs a pair of solutions of Painlevé 6. Now, here's a point about equivariant instanton bundles. So basically, I got to work on these with Gil Bohr back in '97 for different reasons than this. We classified equivariant instanton bundles. These are rank 2 vector bundles constructed by monads through this very interesting algebraic geometric construction. And what we did is we constructed classified the SL2 equivariant ones, and there's a countable family of these. And for any given charge or second Chern number, there's at most 1, which was kind of interesting. We were interested in it for other reasons. But what this paper, my recent preprint, is about is using this to generalize Hitchin's construction, that for each of these equivariant instanton bundles, this is the Hitchin E0 case, the trivial bundle case. For each of these other non-trivial bundles, I've constructed a pair of solutions of Painlevé 6. And furthermore, these solutions fit together by explicit Schlesinger-Okamoto transformations. So these are explicit birational transformations between these functions, and these are inverses of these. This is proved by computation of all these things for m between 0 and 4. And so this table, you would think it continues. It conjecturally continues, but I've only proved it literally up to 4. So I will discuss that. And the reason I'm interested in this is because I'd like to know whether there's a similar structure between the equivariant instanton bundles, starting with Hitchin's trivial ground state. Is there a way to generate the next equivariant instanton and next one and so forth by something like the creation and annihilation operators familiar from the quantum harmonic oscillator? So this is what my talk will be about. Thank you for your attention.